Hello, Math 30-2 students. We're looking at lesson 3.3, probabilities using counting methods. So we're going to relate this back to permutations and combination questions. So what we want to remember from permutation is order matters. You need to figure out if it's a P or for permutation or a C for combination where order does not matter. So when we read the question, we're going to figure out if it's a permutation or combination first before we continue. Example number 1. The Athletic Council decides to form a subcommittee of 7 council members to look at how funds raised should be spent on sports activities in the school. There are a total of 15 athletic council members. There is 9 males and 6 females. What is the probability that the subcommittee will consist of exactly 2 females and 5 males to the nearest hundredth? So in this case, when you're creating a committee, they're not telling you what jobs they're doing in the committee. They just tell you that they want a certain number of males, a certain number of females. So that would be a combination question. So we're going to use the letter C. So our want is the statement that they say in the last sentence. This is our want. Whenever we're trying to answer this question of probability, we always have to write want over total. Our want is going to come from doing a committee of 2 females and 5 males. Okay, so we would say, well, if I want to pick 2 females, I need to say how many are there? Well, that's going to give me there's 6 females to choose from this information here. Choose, I want 2 females, so it's going to be 6 choose 2. Whenever you see the word and, you are going to multiply. And now from 9 males, right here, you are going to choose 5 males. So that's our want. So that's what the actual statement wanted. Now, the total comes from saying how many people are selected, or how many people am I selecting, and how many people do I need for the committee? Well, the total, well, if I didn't care if they were male or female, there would be 15 people to choose from. And I want to make a committee of, it says that you want to make a subcommittee of 7 council members. So you're going to go 15, choose 7. So this is going to be our want over our total. So what we're going to do is we're going to put the top, the 6 choose 2 times 9 choose 5 into our calculator. We should get 1890 over, if you put 15 choose 7, you should get 6,435. Now we're going to write it to the nearest hundredth. So in your calculator, you're going to divide these two numbers. And you should get to the nearest hundredth would be 0.29. So that's our answer. Example number 2. Jessica, Daniel, and Tom are attending the grad mass and want to sit together, but they are being arranged by the grad coordinator. They know they will be in the same row, but there are 6 other people in the row. What is the probability that Jessica, Daniel, and Tom will be sitting next to each other to the nearest 1,000th? So that means you're going to have 3 decimal places. That's what 1,000 means. Decimal places will be 3. Okay, so in this case, we're going to have spots to represent this. So we're going to show what this looks like as spots. So we know that they'll be in the same row, but there are 6 other people. So there's Jessica, Daniel, Tom, and 6 others. 1, 2, 3, 4, 5, 6. So when I'm trying to do these situations where people have to sit together, I'm going to put them in the first 3 spots just for now. And we're going to rearrange them by saying that there's 3 options for the first spot because it could be Jessica, Daniel, or Tom. Then if I put 1 person in the first spot, there's 2 people left. And if I place the second person, another person in the spot 2, there's only 1 person left. So that's going to represent 3 factorial. Now, the other people, I'm going to rearrange by saying there's 6 people left, then 5, then 4, then 3, then 2, then 1. Now, whenever we have situations where people have to be together, we need to say where they can go. Well, they could be in the first spot, in front of the 6th. They can be in between the 6th and the 5th person, in between the 5th and the 4th, in between the 4th and the 3rd, in between the third and the second, in between 2 and 1, and finally in the last spot. If you count all these arrows, there should be 7 spots that they can go into. So you're first going to write 6 factorial, which came from all this, and then you're going to multiply by the 7 spots that those people could be sitting together in that row. So another way of writing this would be 3 factorial multiplied by 7 factorial. Now what we just did was we calculated the want. Because of the word probability, we have to write want over total. So that's what's different about this lesson. Our want is going to be that 3 factorial times 7 factorial over the total is going to be, well, what if there's no rules and we just have to rearrange these people in that row of 9 people, because there's 9 people in the row. So imagine you have 9 spots. Well, if there's no rules, you can have 9 people in the first spot, then 8, then 7, then 6. So that's the same as saying 9 factorial. Okay, so we would put this into our calculator. The top would equal 30,240. The bottom would equal 362,880, which simplifies. If you go into your calculator and press math, enter, enter, you should get the answer of 1 over 2. So again, you're putting this into your calculator, and then you're going to press math, and then enter and enter again, and you'll get that it gives you this 1/2. Now we do want to write this. Oh, sorry, my bad. Should not be 1/2. I was just checking my calculator. Just going to erase this. Okay, so 30,240 divided by 362,880 gives me, so it should be math, enter, enter. It should have been 1 over 12. I'm just missing 1 over 12, which they want to the nearest 3 decimal places, so you would have to write the answer as 0.083. So that's the answer that they were looking for. Example number 3, suppose that Blake had 1 daughter with him at the mall and 4 children at home. Okay, so we have with him at the mall, there is 1 daughter. Oh, and previously I just wanted to explain that in example number 2, this is a permutation question because they're being placed in seats and order matters here. This next one, here, order does not matter. This is a more fundamental counting principle where we just have to use spots. So we're talking about, we have a child with him and he has 4 at home. So we're going to have 4 spots, 1, 2, 3, 4. Now, since we know that the first spot, meaning the one at the mall, is a daughter, there's only one choice there. And then we have to figure out how many different options there are for the kids at home then. Well, let's say we talk about the first kid at home. There's 2 choices. It could be a boy or a girl, so we would put a 2 there. The second child at home could be also a boy or girl, so 2 choices. Third child, same, boy or girl, and fourth child at home, boy or girl. You're going to multiply all these numbers, and this will actually equal our total, which is 16. So when we have our want over total, we're going to have 16 at the bottom because there's 16 different outcomes that can occur. Now, we want to figure out how many ways can all 5 of Blake's children be girls. Well, there's 5 spots. We know that the first one's going to be a girl. The second one's going to be a girl. The third one's going to be a girl. The fourth one's going to be a girl. The fifth one's going to be a girl. If you multiply all these numbers, you get 1. There's only 1 out of 16 possibilities that you will have all of Blake's children being a girl, being girls. So that's your answer. Now, at least one of Blake's children is a boy. At least means that you could have 1 child being a boy, 2 children being a boy, 3, 4, 5, all the way up, right? So there's a lot of options. We're going to actually use that indirect reasoning idea. it makes it way easier to solve a question like this. Reason being that the total, meaning all cases, should always add up to 1 if we're talking about fractions or decimals. Or if we're talking about percents, it would add up to 100%. So we know that the total is 1. We're going to subtract from it the opposite of this case. If we know that we want to have a boy, well, what if we had no boys? That would be like that indirect reasoning where we're taking no boys and subtracting it from our total, and that's going to give us no girls. It should be over here. If I fix this, this should actually be no girls. If I want to have a boy in it, the indirect reasoning, the opposite of that would be, yes. So the indirect reasoning for this would be, what if they're all girls? All girls. There you go. All girls. Okay, that's better. So remember, if we have 1 boy, 2 boys, 3 boys, there's never going to be a possibility that there's all girls. So that would be what we have to subtract. So what you're going to do is take this answer and you're going to subtract it from 1. You're going to go 1 over 16 subtracted from 1. If you're doing fractions, you always want to get the same common denominator. So 16 over 16 is the same thing as 1. And what we're doing, so this is still our total. Instead of 1, we're writing 16 over 16. We're subtracting the time where there is all girls, which is 1 time out of 16. And then that means that every other case, meaning 15 cases out of 16, will have at least 1 boy. So that's our answer. So indirect reasoning, we took 1, subtracted where all of them were girls, and we got every case where there would be a boy. Example number 4. So Bo hosts a morning radio show in Saskatoon. To advertise his show, he is hosting a contest at the local mall. He spells out Saskatchewan with letter tiles. Then he turns the tiles face down and mixes them up and asks Sally to arrange the tiles in a row and turn their face up. If the row of tiles spells Saskatchewan, Sally will win a new car. Determine the probability that Sally will win the car. Well, this is a permutation question because order matters. If you turn the letters over and it doesn't spell Saskatchewan, you mix the A and the S together, or the A and the S spots, then you're not gonna win. So order does matter here. So we're gonna figure out our total. Remember, it's always gonna be want over total when we're talking about probability. Our total is gonna come from rearranging the letters of the word Saskatchewan. Well, whenever we rearrange letters of a word, we count how many letters there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters in the word Saskatchewan. So I would have 12 spots with 12, then 11, 10, 9, all the way down. Now, if there was no repetition, meaning no letters that were identical, this would be my answer for the total. But we actually know that there are 2 S's and there's actually 3 A's. So you want to check to see if there's any other things. So we got no more K's, no more T's, no more C, H, E, W, A, N. So check that there's no other things. So what we need to do is with the 12 factorial, we need to divide out 2 factorial and 3 factorial. And you put that in your calculator with brackets around it if you're doing it in one step, and you should get 39916,800. Okay, so your total will be that number. Now we have to figure out how many ways are there to turn over the tiles and spell Saskatchewan. Well, if we get rid of the repetition just like we did before, there should only be one correct way. So there's only one correct answer. Okay, so only one correct answer needs to be done for the top. The want is to spell Saskatchewan one way. And then there's a lot of ways to rearrange the letter, so that was where we got that big number at the bottom. Now, what if you have Saskatoon? So let's figure that out. Want over total, we're talking about probability. We would do a similar thing. We would count how many letters there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 factorial divided by repetition. There is 2 factorial, meaning the 2 S's. There's 2 A's and there's 2 O's. Put brackets around it. If you're putting it in your calculator, you should get 45,360. So just like in the previous case, there's only one way you could spell Saskatoon over 45,360 different arrangements. Now, from this, we would find out that Sally's probability of winning would be greater in this case versus A. So she has a greater chance of winning in B. The reason being, when your total number is smaller, then you have a better chance of winning. Example number 5. So there are 10 bikes in Marnie's spinning class. So we have 1, 2, 3, 4, 5, and there's 2 rows. 1, 2, 3, 4, 5. With 5 bikes in each row, Allison, Brett, Carol, and Doug, and Franco each call the gym to reserve a bike. They hope to be in the same row, but they cannot request a specific bike. Determine the probability that all 5 friends will be in the same row with Allison and Franco on either end. Okay, so we want Allison and Franco on either end. So let's say they're in this row. We're going to place them now in this row. If Allison and Franco have to be on either end, we can make Allison and Franco go here, and whoever's left will go in the last spot. So there's 2, 1 to rearrange Allison and Franco. And then there's 3, 2, 1 left over because Brett, Carol, and Doug have to still be placed. Now we still need to remember that there are other people that have to be placed as well. There are 5 other people attending this class. So we could have 5, 4, 3, 2, 1. Okay, so what we're doing is we're writing 2 factorial, which represents Allison and Franco. This is our want that we're creating right now. Multiplied by, there's 3 other friends, Brett, Carol, and Doug, that have to be placed. Now, then there's the 5 other people that are strangers to them that have to be seated in the other row that have to also be rearranged. And finally, they could go in this row or this row. So we're going to have to multiply this whole answer by 2 because there are 2 rows. So this is our want here that we're creating. So we would put that into your calculator. 2 factorial times 3. And you should get 2,880. Okay, so check that you're getting that number. I'm just triple checking. Yep, okay. And then the bottom would be your total. Your total would be, well, what if there were no rules? There's just 10 bikes and I have to rearrange 10 people that are going to be coming to this this spin class. So I would just go 10 factorial. 10 people rearrange is 10 factorial. So that would give you, in your calculator, 10 factorial would be equal to 362 8800. So it'll be 3,628,800. Now finally we want to simplify by going math enter enter, and you should get that this number is 9 over 11340. Okay, so that's going to be 9 over 11,340 as your answer. So if they don't tell you that they want to the nearest hundredth or tenth or thousandth, you can leave it as a fraction if you want as your final answer. Okay, our next case is those block ones. So what we're going to have to do is find our total. So our total would be going from home. It says, Tuyet loves to vary her walk to school. Oh, and previously, guys, this was a permutation question because it's a seating arrangement, the biking arrangement, so order matters. Okay, back to group work. So what we're trying to find is that she's varying her way to school. At each intersection, she randomly walks either she can go south or east. So she can only go down and to the right. Determine the probability that she will pass the pool on her way to school. Well, first we need the total. The total would be going from home to school without having to go and pass the pool. So back in the day, we put ones along the edges, and then we would add up 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. 5 plus 1 is 6. And then 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. 15 plus 6 is 21. 3 plus 1 is 4. 4 plus 6 is 10. 10 plus 10 is 20. 20 plus 15 is 35. 35 plus 21 is 56. Then we have 4 and 1 is 5. 10 and 5 is 15. 15 and 20 is 35. 35 and 35 is 70. And then 70 and 56, I'll go to my calculator. I get 126. So I know my total is 126. Whenever you're trying to find probability, you still need to figure out the want. And in our case, the want is going through the pool. So want is going through the pool. So I'm going to erase this and start all over again. So again, we can only go right and down, but we have to go through this without going past it and then through here. So it's kind of going to look like this, because here, if I go to this next spot right here, I would not be able to go down and go through the pool. So it doesn't make sense to go past the pool either horizontally or vertically. Okay, so along the edges I should have ones, then 1 plus 1 is 2. 2 plus 1 is 3. I don't want to go lower because then I won't go through the pool. 2 plus 1 is 3. 3 plus 1 is 4. 3 plus 3 is 6. 6 plus 4 is 10. So now I'm going through the pool. Again, I don't want to go anywhere outside of that box that I created, because that would be going backwards or up when I should be only going down and to the right. So then I should have 10 here, 10 here, 10 here, 10 here, because there's no other numbers coming down towards them. And then you would say 10 plus 10 is 20, 20 plus 10 is 30, 20 plus 10 is 30, and then 30 plus 30 is 60. So that is our want. So we're going to have 60 over 120, which we'll put in our calculator because it does want the answer to the nearest tenth. So that would be 0.5 if you round to the nearest tenth. Okay, so that is lesson 3.3, using counting methods. So this is kind of reviewing permutations, combinations, in order to answer the question. The reason this is different than our previous lesson is just because of this word. This word changes what we're doing.